Good morning, everybody. Today we're going to continue Chapter 1 by looking at measuring time and temperature. Now, where time is concerned, we will be using throughout the year both digital stopwatches and a CPO data collector, which also measures time for you. We'll learn more about the data collector later. However, today I do want to look at the digital stopwatch so that you understand how to read the face of the stopwatch. When you're looking at a digital stopwatch, the form of the measurement it gives is digit, digit, colon, digit, digit, dot, digit, digit. And over here it shows as 2 zeros, a colon, 2 zeros, a decimal, which you can't see right there, and then 2 small zeros. Now, what do those mean? Well, the 2 capital D's right here, which are the first 2 zeros, represent minutes, and you can have anywhere from 0 to 59 minutes shown on the watch. The second 2 D's, which are lowercase and come right after the colon, these are whole seconds. They would be these 2 zeros here. You can have anywhere from 0 to 59 seconds. The last 2 digits, which come after the decimal, are indicated by these tiny zeros. Those would be the tenths and the hundredths of a second. So let's see how we would correctly read measurements on a stopwatch. Look at these examples here. On the first stopwatch, you have 11:25 decimal 22. So that would correspond to 11 minutes, 25 whole seconds, 2 tenths, and 2 hundredths, or 25.22 seconds. So 11 minutes, 25.22 seconds. Why don't you take this opportunity real quick to go through these other 3 images and see if you can write down correctly what those measures would be. Let's check what you have now. On the second stopwatch, you have 12 minutes, you have 6 seconds, and 41 hundredths, 4 tenths and 1 100th, or 41 hundredths. Okay, so 12 minutes, 6.41 seconds. On the third stopwatch, you have 9 minutes, then you have 3 seconds, and 19 hundredths, so 3.19 seconds. On the last stopwatch, there are 0 minutes, 37 seconds, and 22 hundredths, so 37.22 seconds. And that's how you read a digital stopwatch. Okay? Let's go on to temperature now. Temperature is basically a measure of how hot an object is. And there are 3 ways or 3 units of measure for temperature on a thermometer. A thermometer is the device that we use to measure temperature. So, 1 unit of measure for temperature is the Kelvin unit. We denote Kelvin with a capital K at the end of the measurement. That's why I'm putting it in the brackets. It's a unit. In fact, the Kelvin unit is the SI unit for temperature. This is the one that we use in the formulas, is Kelvin. There are 2 other everyday units of measure for temperature that we use. One is degrees Celsius. And at the end of a measure, we'd put the little degree symbol, which is a superscript little tiny O, and then a capital C for Celsius. Another common way of measuring temperature is degrees Fahrenheit. Now, oh boy, how do you spell Fahrenheit? Wouldn't you hate to have had his name growing up and learn how to spell it? So we get capital F, and then it's AHRENHEIT, Fahrenheit. And at the end of the measure, we would put the little degree symbol and then a capital F. Now, over here on our picture, which mine turned out real light because I'm losing my color ink, the first thermometer scale is actually the Kelvin, the second is the degrees Celsius, and the third is the degree Fahrenheit. Now, these three scales are a little bit different, even though two of them are quite similar. I want you to notice on the Fahrenheit scale, look at the increments from one space or from one number to another. The spaces are very small compared to the Celsius and the Kelvin. In fact, if you look closely, the increments for Celsius to Kelvin, even though the numbers along the side are different, the spacing is exactly the same. That's because 1 Kelvin degree is the same size as 1 Celsius degree. Isn't that interesting? But the Fahrenheit is much different. Also, if you'll look at the scales, where 0 is located is also different. Okay, for example, on the Fahrenheit scale, freezing water is 32 degrees below the 0 mark. Excuse me, not below, I'm sorry, just above the 0 mark. But the boiling point is 212 degrees above the 0 mark. When Mr. Celsius decided to make his thermometer, he chose to let the freezing point of water be the 0 point, and boiling water would be the 100 degree point. So his increments are spaced evenly between the point where water freezes and where it boils. But that's different from this one. 0 is below the freezing point, and boiling is way up here. And both of them are odd terms. You have to remember, oh, it's 32 for freezing and 212 for boiling. Here, 0 and 100. Much easier to remember. The Kelvin scale 0 is actually way down here. In fact, the Kelvin 0 is negative 273 Celsius and negative 460 Fahrenheit. Now, why there? How did they know why did they put the 0 there? On the Kelvin scale, the 0 point is actually called absolute 0. Now, what in the world does that mean, absolute 0? In other words, that is the temperature where there is no more heat content in an object. If an object is at absolute 0, it has no heat content at all, and all motion stops because moving objects contain heat. So 0 on the Kelvin scale is set where there is no motion, no movement, and no heat content. Okay? The freezing point of water at Kelvin is 273 degrees above that, because that's where 0 is on the Celsius. In fact, notice the Celsius scale, 273, and the Kelvin scale are the same increments. It's just the 0 is located here for Kelvin and here for Celsius, and this would be negative 273 for the Celsius. So that actually means we can convert from Celsius to Kelvin fairly easily, because any number you read on the Celsius scale is going to be 273 degrees larger than the Kelvin scale. So look, for example, right here. If we had 76.5 degrees Celsius and we wanted to convert to Kelvin to use in our formulas, since Kelvin is the SI unit, then we would take 76.5 and add 273 to it, and that would tell us what it is on the Kelvin scale, because the Celsius is going to be 273 degrees bigger in value than it is on the it's going to be 273 Kelvin bigger than it would be on the Celsius scale. So it would be 349.5, or way up past here on the Kelvin scale. Okay? On this example, 27 degrees Celsius, you would say 27.0 degrees Celsius plus 273 more degrees, and that's going to tell us the Kelvin, which is actually 300 in this case. So all you have to do to convert from Celsius to Kelvin is simply add 273 to the Celsius measure to get the Kelvin. Pretty easy, isn't it? Now, we will at some point learn how to do the Fahrenheit conversion too, but not right now. All right? Thank you very much for listening. Bye-bye.